All right, so we are going to continue with our part two on introduction to databases. So for this topic, we are going to cover the following. So some relational database terminologies that we need to be familiar with so that you will not get lost later on as I discuss a little deeper on databases. Relationships and types of relationships, how to design a database, although we have a more specific topic on designing the actual database later on. That it will just be an overview. And characteristics of a well-designed database, some database designed to avoid, and of course, how to maintain data and file processing versus databases. All right, so when it comes to database terminologies, I hope you will not get confused with this one because a lot of students will easily get confused. But basically, the terminologies in databases is not that difficult to understand. So when we talk about data, this is basically referring to a number or a value that is found and stored in your database. When we talk about information, this becomes a process data, so making it more relevant and meaningful. Then when we talk about null, null is something that is used to present a value that is unknown or missing. A null value is neither zero or blank. Yep, it's a little bit weird, but yeah, that's how it goes. Table, the main structure in the relational database, so it is composed of your attributes, which is also called as fields. And then domain or records, on the other hand, it could also be considered as rows. Then you have file. The file is an organized collection of related records about a particular entity. Then we have a record, which is a group of related fields relating to a specific first person. So this is one I have mentioned earlier. So you have 4 different names for this one: domain, records, row, and the last but not the least is called tuple. So take note of that 4. They mean the same in when it comes to database terminologies. Then we have the field. So the field is a combination of one or more related characters. So field name could uniquely identify each field in a record. So let's say, for example, your personal information. You have your first name, last name, middle name, birth date, and so on. So all related to your personal record. View is actually a virtual table. We'll get to know more about that one later on. Then we have keys. Keys are actually, they serve a specific purpose within a table. When we talk about primary, they refer to as the identifiable field for each record in a table. For foreign keys, usually these are primary keys from the original table that are utilized or act as foreign keys because they are being used in a different table. I hope you're able to imagine that one, but we'll give you a more detailed discussion on that one later on as well. Then the relationship, they exist when 2 or more tables have connection or association. Okay, I don't want to bore you with my face, so I'll hide for a little bit. Relationships. Talking about relationships, this doesn't mean your relationship about the boy-girl relationship. This is a little bit different. This is a relationship in relational databases. So this exists when 2 or more tables are connected by the following conditions: your primary key, your foreign key, and the linking table, which is the one connecting these 2 tables. What is the purpose of this one? They ensure data integrity actually, because later on we'll try to eliminate duplicate and redundant data. This also helps us as a means to define views. Another one is the types of relationship. The best relationship for us is actually one-to-one, of course. Stick to one. But of course, this does not refer to the way the one that I meant about our relationship between each other, but Again, we're talking about database relationships here. So one-to-one relationship, to one-to-many, and many-to-many relationship. In a one-to-one relationship, this relationship exists between tables when only one record of the first table is related to only one record to a second table. So can you imagine in a salary table versus an employee table? Now, between these two tables, there can only be one-to-one relationship because in a company, it's going to be impossible for you to have two different rates at the same time, right? So an employee 001 will have a corresponding salary in the salary table. So as you can see here, the employee ID is a primary key in the employees table. Once it goes in the secondary table, it acts now as a foreign key. But in this case, the relationship must only be one to one. It cannot exist several times. Okay, this time we talk about one-to-many relationship. This relationship exists between tables when one record of the first table can be related to one or more records to a second table. So that means you have to make sure that any record of that particular, in this case, I think the publisher code must also be existent in the first table. So only one record from the second table can be related to a single record in the first table. So the publisher code is a primary key in the publisher table. However, in the books table, as you can see there, the publisher code is actually repeating because actually the publisher code is going to be possible that he is publishing several books and it refers the publisher is the same company or the same publishing company. Yeah. Now, there's also what we call the many-to-many relationship. This relationship exists between tables when one record of the table, of the first table rather, can be related to one or more records also to a second table or vice versa. So in this case, the relationship of the table is actually vice versa. So if you're going to look at it, in this case, uh, the student here can be enrolled in what math, science, or computer. In the same way, a computer can also have several students. So this is how it's going to be evaluated. But nevertheless, don't worry, we'll have a much more detail when it comes to many-to-many relationship later on. When designing a database, we want to make sure that we know the very purpose of the database that we are designing. So there's a way for us to determine the fields needed and the corresponding tables. Then we identify the unique fields, which will serve as the primary keys. So it's important that every table must have a primary key. We also determine the relationship between tables. Sometimes we could refer the tables here as the entities, which we will get to know more a little bit later. Then we also have to test the design by entering some sample data. There's actually a formal process in terms of how we design the database, but we'll get to know on that one later on. So here are some characteristics of a well-designed database. So modifying data is easy. Okay, retrieving information must also be not that complicated. Developing and building user applications should also be allowed. Maintaining the database structure is easy, but maintaining the structure doesn't mean modifying it at the same time because it's going to affect a lot. There will be a lot of changes that's going to be happening, especially if the database is not well designed. And adding and deleting of data is there, although deleting data is not something that is going to be allowed easily. It has to be avoided actually. Database designed to avoid. I believe you are all familiar with spreadsheet, but it's not the best way to follow the spreadsheet design. It's because in a spreadsheet model, we cannot easily relate the values that we are encoding in each cell and its corresponding row and column. So it's not the best way possible to store data. Then we have also what we call the spreadsheet view. So sometimes there are those database people who are really keen to looking at a spreadsheet view. But you should avoid looking at it as in a spreadsheet view mentality, because it just that's databases doesn't always work the same way as spreadsheet. That's really the bottom line. So when we build databases, we will have to have database management system software. So this is where we base the needs also on the organization. And it's very important that we look into and evaluate the data integrity as well, because this will affect the design of the database that we are trying to build. So there must be some form of consistency that we have to maintain. So database software also are the tools to achieve the objectives of a database. So there are common things that a DBMS has to offer nowadays. Maintaining data is something that each database has to offer. File maintenance refers to the procedures that keep data current. So we want to make sure that data is current. Otherwise, the database administrator can actually perform, or the system itself can perform purging. So the data are purged or deleted when they are no longer required, or there are those instances that this data is safe to be deleted. Of course, procedures also involves adding records, modifying records. So modifying doesn't mean changing it into something bad, but to correct inaccurate data and to make sure that updated or old data are updated. Yes, deleting records must also be there. So records that are no longer needed rather can be deleted. It is important to validate data. So validating data is important for every database and information system that is going to be utilized in every organization. So many programs perform validity checks. So this is basically or best practice coming from the application point of view, because the application itself is the point of entry of the data. So some example of the validity checks here. So you may have notices the invalid data column. So those things must be avoided as much as possible, or it will already be detected upon entry into the system before it is being saved into the database. File processing versus databases. So file processing systems, the records in one file may not relate to other records in other files. So this was the older version, or this is how data storage done in the past. So in a typical file processing system back then, each department or area within an organization has its own set of files. And that is actually very, very difficult to manage. And this leads to two major weaknesses within how the data are being managed. So one of those is data redundancy, and the other one is data isolation. It is very important to consider that when we are doing a file processing, we have to consider these scenarios. As you can see, we have to evaluate even the process within the organization, how data are being captured, and then process any further. What we have here is actually an example of a file processing versus a database example. The file processing are normally utilized in the legacy systems back then, and it's a little bit difficult to handle because the data are duplicated in this instance. Just imagine each department, let's say sales and marketing, have its own data. It has its own list of data for the customers. And both of them will have to have the same file as much as possible, right? In order to maintain or to make sure that data is current. Now, what if your marketing data or the marketing department rather, has an updated list compared to the sales. So that's where the problem comes in. And it's also difficult to see whether who among them is actually has the updated version of the data. So it's really a challenge back then. Another example is the database. In the database, it's a little bit different already because in a database example, normally the data are centralized. They are stored in a central database, and all the systems, all the departments access the same data. So let's say, for example, in this instance, you have here a schedule of classes file and your instructor file. So it's very important that your instructor ID must be coming from the instructor file, not that you are going to create another instructor record within the schedule of classes, just like what is happening in file processing system. So this is a very good example in terms or between the two in how data are being processed. So why is this very important that we understand file processing, even though we're no longer using it? The bottom line really is for us to have a better understanding, probably an appreciation to what we have currently, because we are not experiencing the same issues that we have back then. And in the database approach, there's actually a lot of help already. So an approach where an organization share the same database to retrieve data and information. Just imagine that one. Back then, each department had their own copy of the data because they cannot yet network the system. So they are stored electronically, but they have their own copies. In the database approach also, it addresses many of the weaknesses that is associated with a file processing system. And those are reduced data redundancy, improved data integrity, shared data, easier access, and there's also what we call the reduced development time. In this example, we are looking at the database here for a school, and the data is shared across the various departments or colleges. So if you can see at the center, the green database icon is actually centrally located. It doesn't mean that this has to be in this format, but the location of the database may always be somewhere else. Especially today, this could be in the cloud. But nevertheless, this is how we could imagine how a database approach would look like. So the programs on registration department, all the data that he is accessing, they are all coming in from the database management system. The student file, the instructor file, schedule of classes, student schedule file, they are all coming from the database as well. Programs on advisors' computers, they are also coming from the database management system. So in this case, you actually have a centralized data. You only have a single source of data. So if ever the registration department updates any record of a student, what the other departments would be able to see is the updated record of that particular student, and that makes things much easier for the organization to work together. All right, here's a simple question for everyone. Can a database eliminate redundant data completely? Any answer? If you're going to imagine, the answer to that one is no. A database reduces redundant data. It does not eliminate it. Because we are going to retain the key field link of that data in order for it to be linked together in the database. Otherwise, we will be able to link each of these tables all together. So it's likely the foreign key acts as a glue to link all the tables in the database. For example, a student ID field will exist in any database table that require access to student data. Thus, a student ID is duplicated in many tables within the database. Can you imagine that one? We are not eliminating the student ID because it's the only way that we could link it back to the student record. So no matter how many of the tables are utilizing the student ID, all these tables, once accessed, they all refer back to the student table. I mean to the student record to get the updated personal information of the student. So there's a single source of your data. All right, that's it for today. So any questions? If you have any questions, guys, please don't hesitate to ask them and write your comments below. I'll try to answer them as much as I can. Thank you and hope to see you in my next lecture.